Hi everyone, namaskara. Welcome to Tech Girl Kannada YouTube channel.
Our today's concept is functions. Let A and B be the non-empty sets. A to B is a relation from A to B, then such that every element of A there exists a unique element in B. Only that time you can say it is a function. Unique element in B. B is a image of A. A is a pre-image of B. So A comma B belongs to function which is a subset of A cross B. We can write it as B equals to function of A, domain and codomain in this pictorial representation. A is also called as arrangements of function, argument of a function. Should be unique image. One is having more than one image. It's not a function. If all the elements is having same image, that is possible. 1 and 2 having same image on B, that is A, that is possible. Here for 3 there is no image, so it is not a function. Every element of A there exists an unique element in B. That is, one is mapped to something and another number is mapped to same A. 1 2 3 everything is mapped to A itself. That is possible, but here more than one image. One is having more than one image, that is 3 images, so it is not a function. Every function is a relation, but every relation is not a function. Let function A to B, A be the domain and B be the codomain. The elements of A is pre-images of B and B is the images. The collection of images subset of B is called the range, denoted by f of A. A comma b1 belongs to the function, A comma b2 also belongs to the function, then b1 is equal to b2. If A comma b belongs to the function, if A is function of B or B equals to f of A are all equivalent. This is the three types of representation of the function. F inverse B, x belongs to A, f of x equals to B. F inverse of B belongs to A. F inverse of B is the pre-images of B. Then types of function. Identity function. If the image of every element of A is itself and denoted by IA, the function from A to A, f of A belongs to A. For every A belongs to A, that is called identity function. Constant function. Let the function be from A to B. F of A is constant, means A for every A belongs to A. Then if the image of every element of A is only the constant, then it is called constant function. 1 to 1 injective function. F, that is function from A to B, if every different element in A have different images in B, that is A1 to B1, that is the 1 to 1 function. A1 to B1, A2 to B2, A3 to B3. F of A1 equals to f of A2, A1 equals to A2. If A1 is not equal to A2, then it is in 1 1 function, then f of A1 is not equal to f of A2. Then there is a thing called onto function, that is surjective. 1 1 function is also called injective. For a function from A to B, every element in B should have the pre-images in domain. f of a equals to b. Preimage of b is f of a. 1-to-1 correspondence, it is bijective. F is 1 1 as well as 1 2 means that is called bijective. 1-to-1 correspondence. Let us see the properties of function. Let the function be from a to b. If there is a function from a to b means a is the subset of b, then f of a is the subset of f of b. F of a union b is f of a union f of b. F of a intersection b is the subset of f of a intersection f of b belongs to this. Equality holds only if f is 1 1. Then f is 1 1, then mod of a is less than or equal to b. F is on 2 means then mod of b is less than or equal to modulus of a. F is 1 1. Because in the b part there will be as many as elements it want to be, and a will be lesser than b. But in on 2, every element in b should have the preimage in a, so b will be lesser than a. Then for bijective, a is equal to b. F is a to b. F is bijective if and only if f is 1 1 and on 2. Then we have a function a to b mod a equals to b. Then f is bijective if and only if it is 1 1 and on 2. For example, the function a to b mod a is m, mod b is equals to n. The number of functions are n power m. The number of functions are n power m. Yes, there will be m will be less than or equal to n. N is a larger number and to the power of some smaller number. That is number of functions. Number of 1 1 function is n factorial by n minus m factorial.
Thank you for watching.